Okay, so we're going to get started. Hi everyone, my name is Harris. I'm a workshop instructor for Record Security Club. Today we're going to be going over the Tor protocol in the Tor browser, as well as advanced digital privacy, just keeping you guys private and teaching you a bit about some really cool privacy tools that are out there. In this workshop, this may seem a little tangential to security. In this workshop, we'll cover the difference between privacy and security, and why these tools not only increase your privacy, but your security as well. So let's get into it. As an overview, first we'll go into a technical overview of Tor and how that works, if you're not familiar with it. Then we'll go into some privacy tools and techniques, some of the best practices that I've collected over time. And then we'll have some demos to get you guys hands-on with some of this. And hopefully in the process learn about it and get you guys configured in a way that works for you. I put this disclaimer here because I just wanted to clarify, I am not teaching you how to evade law enforcement at all. They will find you even if you do this stuff. So this workshop is purely meant just to increase your privacy for you personally. Like I will mention later on in the workshop, this is primarily targeted at reducing, for example, targeted advertisements or like corporate surveillance for like data brokers, which are becoming more and more common. So that is the purpose of this workshop. I wanted to clear the air there. Please don't do anything illegal. So here we go. We're going to get into the Tor technical review. How many of you are familiar with Tor? Just show of hands. Okay. Fair number of you. Okay, great. So for those who aren't familiar with it, Tor is what's considered an overlay network. So it works on top of the internet protocol, which is, we talked a lot about different networking protocols in our last workshop. It's free and open source. So this is given free of charge and open code to the world from the Tor project. And it enables you to have secure and anonymous communication over the internet. It was developed in the 1990s. Onion routing was developed in the 1990s by the Naval Research Lab. And I want to pose this question to you to think about, why would the Navy release this to the public if they were developing it for their own private communication? Yeah. Exactly. Yeah. So just to reiterate it for the people on Zoom, the answer was if more people use it, then the anonymity is increased that way. Because if I just develop this brand new protocol, nobody's ever used, it's completely new to the world, and then I have like only Navy people use it, well, guess what? You can identify all the Navy people based on the protocol that they're using. So they released it to the public. They said, hey, here, we've developed this anonymous system, this onion routing protocol. Go use it. And that way, everybody could benefit from the anonymity, including the Navy, because now it's not, it's a needle in a haystack problem compared to just, a simple fingerprinting problem of identifying people who are using Tor. After the Navy released it to the public, this continues to be maintained by the Tor project and is supported by the Electronic Frontier Foundation. Both those organizations do really great work. I'm not going to have time to get into all of their work, but we'll see how they support a lot of projects and a lot of the tools that we'll be talking about. In general, onion routing, the primary principle behind it is you want to encapsulate your data in multiple layers of encryption. So in this case, you can see there are multiple different layers, each supported by a different cryptographic key. We haven't gone, in this year, we haven't gone too much into encryption, but these work similar to actual physical keys. If you don't have the cryptographic key, this digital item that can unlock the data that's been encrypted by a certain protocol, then you're not going to be able to read the data. It'll be completely scrambled. In fact, we saw in the last workshop during the demo, we saw what encrypted data looked like. HTTPS data over the network. It just looked like random binary mess. So in this case, a client, you, has access to 3 encryption keys, which encrypts a message in 3 different layers. And this is agreed upon with the circuit of nodes that you'll be working with. And we'll get into that in the next slide. At each node that you go across, there are 3 in a typical Tor circuit. each node will strip a layer of encryption off. So at your entry node, it'll receive the 3-layered encryption. It'll strip one layer off, pass it to the middle node. The middle node will then strip another layer off. And then finally at the exit node, it'll strip the final layer off. And this doesn't have to be 3 layers. It could be as many layers as you want. The idea is for every layer of encryption, there's another hop in the chain. The problem with that is as you increase the layers of encryption and the number of hops, the speed of the connection decreases significantly because, well, I should say the latency. These hops can be all over the world. Tor nodes can be hosted by anybody, anywhere, all over the world. And the way they're chosen is essentially random. So, and we'll actually explore this once we do one of the demos. Your Tor circuit could be in the Netherlands, then Turkey, and then all the way back to the United States. And that's a big distance to cover for a network packet. The important thing is about how this protects your anonymity is the entry node only sees your IP address and all the encrypted data. The output node, all it sees is the decrypted data and the server connection. And in the middle is all the bouncing around the Tor network, and all of that data is encrypted. And there's no correlation between your request and your destination. Are there any questions on this before? Yeah.
Does it make it more likely for the packet to be dropped in this case since it has to route through so many servers?
Yes. So then in that case, we talked about transmission control protocol in the last workshop. Protocols would have to resend the packet and handle that performing, or even if the packet got corrupted, they'd have to perform error correction, further leading to the slowness of the connection. We'll see when I show you the Tor browser. You're not getting gigabit network speeds on this. It is extremely slow, but you get anonymity and security as a benefit. Good question. Any other question? Yeah. From what I understand, the encryption keys are based on the circuit because each node you agree with a node on a certain encryption key. You do a key exchange with the node where you say, I'm going to use this protocol, you use this protocol, and then we'll generate a key to use for this connection. I think by default, the Tor browser will refresh a circuit every 10 minutes. So that means every 10 minutes, you're getting another 3 nodes with another 3 encryption keys. I don't think they do it on a per packet basis. Yeah. Yes. Because remember, for each key, you have to go through key generation. Those keys have to go through the Tor network back to the client to agree upon it. It's a lot. There's a lot of infrastructure around making that happen. Any other questions? Any? Okay, good. Cool. So Tor takes this concept of onion routing and uses it in a clever way. Tor establishes what's called a SOX proxy. This is a standard protocol that is used to establish proxy connections with with a client and a server. And then it routes this traffic through that proxy through what's called the Tor circuit. The Tor circuit is, like I said, 3 or sometimes more nodes. Typically your entry, middle, and exit node. And then those nodes each have your layered encryption, like we saw previously. To communicate with what's called a hidden service, this is a website on the Tor network. They end in a .onion address, which we'll see. To communicate with those hidden services, what it does is actually both of them create separate circuits to a middle node, and that middle node handles the exchange. So that way, not only is your traffic not attributable to you, the server's traffic is not attributable to it, and neither of you are attributable to each other, which makes it a completely anonymous connection between you and a website. And the way that it forms this connection, it creates essentially one big Tor circuit. And there's a YouTube video that I have at the end that if we want to watch, it goes a bit more into detail with that. There are some flaws with Tor. The Tor network has never been totally de-anonymized, but I wanted to point this out because Tor is not a magic bullet. There are weaknesses that can be exploited on the network. The main potential flaw is if an adversary is listening at both the entry node and exit node, and they're able to correlate the data based on the time that the packets are sent and received, they can de-anonymize you. They might not be able to, well, if they're listening on the exit node, they can read the data. So that is a vulnerability. The problem with that is if there was a nation state actor or somebody who registered a bunch of malicious Tor nodes, that increases the probability that their nodes show up on your circuit. And if one of those is an entry node and one of those is an exit node, then they have essentially just de-anonymized you. There have been instances over the years of malicious Tor nodes being on the Tor network as a way to attack the network. However, over the years, there have also been increased moderation and verification schemes to also increase the security of the network. And there are other flaws as well that tend to be a bit more niche than this. This one I would say is like the main concern. The nice thing about it is the more Tor nodes that are created, that overall lowers the probability that you're going to end up with a malicious node on the network. Like I said, bad OPSEC or bad operational security, basically that talks about like how you behave like in the real world or on what's called the ClearNet, which is just the internet. That is the most common cause of de-anonymization, where people through other habits lead to their Tor traffic being de-anonymized, not the Tor network itself. Any questions on this? Okay. So to actually use Tor, you have to use it through an application. These are an example of some applications or software that use Tor. You can use it for secure and anonymous file sharing through a thing called Onion Share. Think of it kind of like creating a Google Drive link or a Dropbox, except that is done through the Tor network. You can also have total OS network anonymization, which we're going to see with Tails. Tails passes all network traffic on the operating system through the Tor network. And then you can also totally anonymize your mobile device network traffic through an app called Orbot, which does a similar thing. It takes your mobile device traffic and runs it through the Tor network. And I believe this is available on both iOS and Android. This is pretty much available anywhere. This is a special Linux distribution, which we're going to get into at the end of the workshop. So are there any questions on Tor before I move on to some of the other digital privacy stuff? Great. So in general, one thing I like to say when I'm talking about digital privacy is everybody has a different personal definition of privacy. And in order to actually become private, first you have to realize what you're trying to become private from. This leads into a concept called threat modeling, which is very important for cybersecurity in general. You want to understand what you're defending against, what you're trying to become private from, in order to effectively implement controls to defend against that. So, for example, if I'm concerned about ads and trackers, I'm not going to want to worry about end-to-end encrypted communication, because unless they're tracking my communications, I want to be worried about browser configurations, phone configurations, and like ad blockers. If I was worried about like censorship from a government, then I'd want to be very, very concerned about my privacy. And that's when you would start implementing more paranoid stuff, which we're going to get into later. Though from what I understand, where you're sitting, you're not under a oppressive authoritarian regime. So, what? Not anymore. Yeah, so in general, for this workshop, what I'm going to be basing it off of is preventing ads and trackers and also corporate surveillance. When I say corporate surveillance, I'm referring to data brokers, and we'll get more into that as we go along. One thing I also want to touch on is privacy versus security. These terms can often be conflated with each other, but they are distinct, even though they are related. I want you to keep in mind that being private and anonymous does not necessarily mean that you're inherently secure. There's a concept like in the military called like cover versus concealment. So you can be hidden in the bushes all you want, they can still shoot you. So just because you're hidden doesn't mean necessarily all of your stuff is secure, but being hidden and secure is preferable to just being secure. And also some security features that We could talk about in the future may make you less private, because if you implement certain security features, those could make it easier for people to fingerprint your device. When we say fingerprint, we mean uniquely identify your device, just like your fingerprint does for you. Although there's been weird things where fingerprints can, like, there are more than one person with the same fingerprint name. Does that make sense? Are there any questions on privacy versus security? And I also, yes. MAC addresses we talked about this, MAC addresses can be used to uniquely fingerprint your device. Some devices do automatically randomize your MAC address. In fact, Tails does. So that's less commonly used unless you're like physically on a network. When I say fingerprinting, a lot of times, like if you're doing web browsing, they can uniquely fingerprint your user agent, which includes what version of the web browser you're using, what operating system you're using, what configuration of the web browser you're using. That can all be used to uniquely identify and say, this is you. So a lot of the privacy stuff we'll be going into and a lot of the tools and configurations that we'll talk about actually work on reducing the ability for people to fingerprint you. Yeah. Are you talking about, because this varies depending on what kind of network you're connecting to. If it's a wired network, there's not really much you can do to not remain undetected from connecting to a network, because you're going to be picked up by devices that are like automatically assigning IP addresses, or based off of your MAC address. For wireless networks, there are ways to like connect to a network but not like set off alarm bells. There is some stuff where and we'll actually, I think either this semester or next semester we'll have a wireless exploitation workshop. There are some ways where you can perform like they might have patched this, but there used to be a way where you could do what's called a DAuth attack and then get on kick people off of the network, steal the encryption key when people try to like re-log on to the network, and then that could allow you to get on without setting off alarm bells. Ultimately, it's very tough to, like, if you're connecting to a network, like completely remain undetected, because good security monitoring will pick that up. It's very easy to pick that up. But there are ways you can remain stealthy. And in like an unmonitored network or a very big network, it's very easy to hide. Just by like being on the network and not announcing your presence by, creating a lot of network traffic. Did that answer your question? Yeah, I don't think, because this is more about data privacy. This isn't really about like, I guess, stealth when attacking a network. Stealth is a big part of like when you're performing a pen test or yeah, it's definitely a factor.
We'll go over that in the threat intel workshop more so. So you'll see how that works at like a nation state level, how they keep themselves concealed. And we'll talk about something called orb networks, which are kind of a more roundabout way of threat actors to use basically the same principles that Tor uses. So.
What he said. That's not exactly my area of expertise, so I apologize if I couldn't answer that question. Cool. Good question. Are there any other questions on some of the stuff we've covered? So here are some privacy best practices that I've kind of picked up over the years. You may be asking, well, like, where do these best practices come from? Like, do we just have to listen to you? Well, no, a lot of these are excerpted ideas from resources that I provide at the end of the workshop, books or YouTube videos that kind of explain this in more detail from people that know more than me. And again, these are tailored to the threat model of avoiding targeted advertisements and against like data brokers and corporate data collection. Ultimately, we're trying to reduce the digital profile that these companies can keep on you. Let me explain a bit about digital profile. So advertising companies, data broker companies, they're incentivized to collect data on you to create a profile about you, for example, an advertising profile, so that they can then target more relevant advertisements to you to then get more clicks, more views, more purchases, profit go up. The problem with that is often that comes at the expense of you getting your data collected. And that is not, conducive to privacy, because then they are holding a profile of you. And I mean, to me personally, that's not okay. And I would hope to the rest of you that also is not okay. So as part of this, I've broken some of my recommendations down into recommendations and paranoid recommendations. The reason I do this is because a lot of people will think like privacy is like an all or nothing thing. It's like either you are private or you are not. That's simply not true. If you take small steps, like very small steps towards improving your privacy, changing a setting or making a configuration change or just using a different piece of software, very, very small steps can have a big impact. Even if you're not going completely off the grid and swearing off technology forever, you can still be private and live your life how you normally would, just with an added layer of anonymity and security especially from the stuff that we're looking at. So in these next few slides, I'm going to go into different areas of technology that I start with, starting with operating systems. I will just straight up say Windows and macOS are closed source, and therefore we can't verify whether or not Microsoft and Apple are tracking you based off of recent Windows 11 updates. I'm not too familiar with Apple, but it is most likely that they are collecting some data about you in order to, because if your laptop and your device and your computers are a gold mine of data, because if you own the operating system like Microsoft or Apple, you can collect data about what applications they open, how long they spend on those applications, your location, depending on if it's a laptop or a desktop computer. There's a lot of data that they can get just from your computer or your device. That it would honestly, as a company, it would make the most business sense to collect that data. A lot of these configuration changes, like for example, in Windows 11, are on by default, and you have to opt out of these. So I want to make you aware of some of them so that you can stay more private. Ultimately, though, what I do recommend, aside from hardening Windows or macOS to be more private, I recommend Linux, mostly because with Linux, there isn't really many opportunities for data collection because there's no centralized entity to collect that data. There was a scandal, I think, in I want to say the late 2010s. Ubuntu started to collect data, or Ubuntu by default had Amazon installed, and that was collecting data. And the company that ran Ubuntu, Canonical, would collect data. And users weren't very happy about that because Linux is supposed to be, anonymous and secure, and they're not supposed to be collecting data. So there are exceptions for sure, but those exceptions are not the rule. And 9 times out of 10, I think Linux will be significantly better from a privacy standpoint than Windows or macOS. But even if you're not familiar with Linux, even if you don't want to install Linux, Windows and macOS can still have their configurations changed in such a way that you can improve their data, improve the amount of data that's being collected. For the sake of brevity, I haven't gone into those configuration changes because they're an extensive list of changes you can make for Microsoft and Apple devices. However, at the end of the workshop, I've provided those configuration changes so that you can make those changes if you want to. We'll see more about my paranoid recommendation with Tails. CubesOS is also another Linux distribution. The idea with that is you essentially run every application inside of its own container or virtual machine, and then it's very, very extreme, but it's pretty secure. I mean, if everything's in its own little container or virtual machine, it's very hard and very rare for malware to escape a virtual machine. It's a surprise when that happens because it's very, very rare and very, very difficult to do, because essentially that means you're escaping one entire computer and jumping over to the hypervisor computer, which is not easy to do. So CubesOS drastically increases the security that way. And also they generally follow the same principles as Tails in terms of, not collecting data and being very, I'll say, well, I mean, amnesiac, in that they don't store much data. For web browsers, I mentioned these because aside from operating systems, these are probably like the second most common way for companies and organizations to collect data on you. A lot of modern web browsers are forks of Chromium. Chromium is Google's open source derivative of Chrome. And I know how I said like Microsoft and Apple might collect data on you and probably collect data on you. Google 100% collects data on you. Like that is a fact that they are collecting data on you. That's really like, that's where Google like makes its money from searches and from data collection from their browsers. That's how they make a lot of their money. That's like a main source of revenue for them. Like it is in their best interest to collect data from these browsers, even Chromium browsers, so forks of Google Chrome. The recommendation I make for you then is Firefox or Brave, simply because Firefox can be customized and configured to be very private and secure. Brave to a similar degree. For the Paranoid recommendation, I recommend the Tor browser, which we will get into in a minute. Yeah. It is, yes. That's why I don't recommend Brave as much. I tend to stick to Firefox. Brave, they do make configuration changes to like the Chromium engine, and they also are more privacy focused, but it is still Chromium, and I still don't recommend them as strongly as Firefox. They also do have stuff in the browser like you can watch ads, I think, to like get like Brave credit or whatever, which
have Tor routing with the browser too.
You do. There is a Tor option within Brave. Obviously, again, I would still prefer the Tor browser, but that's why I recommend them, because it is like I said, it's a convenient middle step if you're switching away from Chrome, because people like Chrome. Like well, not your RAM doesn't like Chrome, but you're yeah.
Is there a way to check like what is being seen on Brave specifically? That's really the only browser I use. I've never had it.
You mean seen as in like see what data is being collected? I'm not sure about Brave. I know for Chrome, a lot of that, like you can connect your Google account to Chrome, and then you can go into your Google account and see all the data that Google has. We could do that as a quick demo before I get into the other two. Like I can go into like my Google account, just show you the heaps of data that Google has collected on you. I'm not sure about Brave though. Yeah, does Brave have like a synchronization account between different devices?
You can, yeah, there's a
You can.
so it ports everything over now.
Yeah, I'm sorry, I'm not sure. I haven't.
Set up everything.
Yeah. Yeah, and also, I mean, for Brave specifically, like any telemetry or data collection would probably be being done under the hood through Chromium. So any data that's being collected by Brave would ultimately, I think, being done by Chromium, not Brave, the browser itself. I don't know. I've never really I'm not an extensive user of Brave. Like I've used it like maybe twice. But I know it's out there and I recommend it to people because people like it. It's a nice browser. There was a question. Yeah. Vivaldi. Isn't that no? Okay, Opera. Vivaldi. I've heard it. I think Opera is the Chinese one, so that's why I don't recommend that one. That's why. I think Vivaldi is also Chromium.
Vivaldi is Chromium based and has like the only thing that is different, I think, is like some certain UI things. Same. But like I think the whole idea is that it's extremely customizable.
Okay. And is it a closed source?
Only certain UI elements.
Okay.
Like everything else is open.
Maybe it was founded by also the co-founder of Opera.
Okay.
An open source browser being developed now called Ladybird, which is meant to be like a clearly like open source browser for people to totally customize, and that's like been crowdsourced for a little bit now, so once that comes out, that could also be like probably somewhere in between the paranoid recommendation and recommendation.
Yeah. The reason like for example, Vivaldi is a very niche browser. The reason I tend to recommend Firefox as well, which we'll get into, is there's a lot of resources out there for configuring Firefox. Like if I Googled how to privately configure Vivaldi, there would be much less resources like for the average person than Firefox. Firefox is like people have like, Firefox is also completely open source and there are known ways to configure that.
Its documentation can be a bit dense.
What about I2P?
Yeah, good question. I2P, I think the Invisible Internet project, right, or Invisible Internet Protocol. I forget the exact acronym, but that's another example of an overlay network. I2P is more of a peer-to-peer network. So Tor is a bit more centralized in that you have distributed nodes that people are communicating through. I2P is fully peer-to-peer. So if you are using the I2P protocol or the I2P browser, your device acts as a node on the network that can then be used to route and share information. I think, does it also use like onion routing or like onion protocols? Yeah. Basically, for I2P, the way I think of it generally is a peer-to-peer version of the Tor network. So it is another option. I don't cover it now because again, it's slightly less popular. But that is another option too. It's the I2P project.
Garlic routing.
It uses what?
Garlic routing.
Garlic routing.
That.
I don't know.
So it provides every packet with a certain part, so you go never one packet, it's always two, and have to beat out that some other go.
So it does it on a per packet basis. There you go. That's the answer to your question. That does per packet. There you go.
It's gonna be slow.
Yeah. Yeah. So that summarizes my browser recommendations. Again, like privacy is a very personal thing. So what works for you is ultimately what will work. Like if I can recommend something, but if it doesn't work for you, don't use it. Like it needs to, if you're not going to use it, then there's no point in having it in order to stay private. So that I tend to recommend these, but like I said, like for you, it's a very personal thing. And it ultimately is up to you, like how far you want to take and like how many steps you want to take or what configuration changes you want to make to do this. And we'll see in a bit about the Tor browser. But that is my paranoid recommendation. Okay, I go a bit more into web browser configuration. I always recommend ad blockers simply because a lot of ads can contain cross-site trackers. And there even are examples of ads that do contain malicious JavaScript code. Where like, for example, if you click on the ad, it can run JavaScript that could install something to your device and security has been getting better about that, but it's still a possibility that there's like malware inside those ads. My recommendation for that is uBlock Origin, which is supported on the Firefox browser. I also recommend NoScript. NoScript is a plugin where you can fully disable or partially disable JavaScript. Which is kind of the new, like that, I would say, I didn't put them on here, the paranoid or the recommendation stuff. That would probably be the paranoid recommendation because stuff relies on JavaScript to work on the web. So if you shut off JavaScript, some stuff will probably not work. But you won't be getting tracked. So, yeah. And a lot of stuff we'll see on the Tor browser. I think the Tor browser, there's a security setting change that we'll make that essentially does this. It disables JavaScript fully. And a lot of the websites on the Tor network like work without the JavaScript that disables.
They were built like 2002.
What?
Because some of them were built like 2002.
Well, they look like they were built in 2002. Yeah. And then also there are configuration scripts. This links to a GitHub page where somebody created a script for Firefox where it can replace the files within your Firefox configuration directory to make recommended changes instead of you having to go to about:config and go through each individual setting and change it. They exist. I've also at the end of this I link videos on recommended changes to Firefox, even outside of just using the scripts. And ultimately, the goal of these configuration changes, while they may seem random and arbitrary, we're trying to reduce the ability of websites to fingerprint your browser. And there are websites that exist. I haven't put them here. I could probably put them in after I share these slides. Where there are websites where you can test like what percentage like secure are you from like fingerprinting, and they'll go through like a round of fingerprinting tests on your browser and see how much information they can extract from that. So, yeah. Are there any questions on this so far? So we've done operating system, web browsers. Good. Okay. Now into the fun stuff. Cell phones. I know I said laptops and operating systems and web browsers are like the #1 and #2 ways they get. This is the #0 way. Well, I put #1, but this cell phones are like the #1 way that personal data is collected. If you think about how much stuff is actually on them, you've got microphones, cameras, location, your calling and texting, any mobile data you use, all of that is present on one device. And it is very easy to fingerprint cell phones for the simple reason that they have a unique fingerprint built into them. It's called an IMSI, an International Mobile Subscriber Identification Number, IMEI. I think are those two different ones? Because there's the IMSI and then there's also the IMEI.
Number, it's the unique identifier. Depends on whether the phone is PSM or CDMA.
Okay, so it depends on the like the cellular technology present on the phone.
Yes.
Okay. That is okay. Yes, that's true. There's an IMSI and then there's also IMEI, which are different versions of that number. That depends on the cellular technology present on the phone. So GSM is, I think, 2G, right? And then up to 3G. Okay.
CDMA is code division multiple
Yeah.
access, so you can only use approved devices and have those in part and so on.
That's the eSIMs.
Yeah. Yes, CDMA phones are in base now, but it used to be like those phones in Verizon and Sprint that you could not put a SIM card in. You
Okay.
put them on any kind of camera.
No, that was so the carrier locked ones.
Yeah.
Yeah. Okay. Cool. But yeah, I think even for an IMEI, I think there are the IMSI catchers are the ones that are famous, but there are also IMEI catchers, I believe. That like, for example, law enforcement uses these typically to for example, I'm trying to think of an example, like at like large gatherings or whatever, they'll use them and it'll log that number for phones. It'll act as a fake cell tower. Phones will ping that, because phones do automatic discovery. Once you grow, like phones are basically tracking beacons, but phones will automatically ping cell towers. They'll send out like essentially discovery requests, and these IMSI or IMEI catchers can record those numbers that are sent out with those pings, which can be used to fingerprint your phone. And there's very little you can do to avoid that. So same thing with like location tracking. A lot of devices now, we don't just rely on GPS. We also rely, this is actually very recent research from like 2022 or 2023. Some researchers at the University of Maryland, they looked into identifying devices or identifying locations based on unprotected API calls to what's called a Wi-Fi positioning system. Wi-Fi positioning systems, it's a more efficient way to position your devices. So for example, if you're on Google Maps or Apple Maps, or you require your location data, instead of having to use GPS every single time, which is expensive and can be inaccurate depending on the area you're in, if you're near a lot of Wi-Fi networks, they can actually be used to position your device based on the signal strength from those Wi-Fi networks. They're the Wi-Fi access points. And those Wi-Fi access points are logged in a Wi-Fi positioning system database that's run by Google and Apple. Each of them run a separate WPS system. And those systems that log the locations of those access points are or were not authenticated. So you could just request where a bunch of access points were. And also, if you sent a packet with, for example, the like structure of the packet similar to how the phone would structure it, then you could actually request up to 200 neighboring access points and then correlate that with the data on the phone. So even with the location services disabled on the phone through like GPS, you could still actually position the phone and position devices that acted as Wi-Fi access points, which was pretty scary. There was some pretty like scary stuff that was going on with that data. So phones, in terms of location access, it's basically a guarantee that they are able to track your location, along with your microphone, camera access, everything else that's present there. So my recommendation for this, long story short, is I typically recommend hardened Android. You can also harden iOS devices as well. Android tends to have just a bit more flexibility in these things. The reason being also my paranoid recommendation is Graphene OS. Graphene OS is essentially a full replacement of your Android operating system. It's free and open source, and it's essentially a de-Googled version of Android that it significantly reduces the data collection opportunities present on your device. For example, like if you they have removed the Google push notifications, all of like the Google services from the device. So there's very little opportunities to phone home, so to speak, to Google. And yeah, if you want to get extreme with paranoid, just get a burner phone with a prepaid SIM, but nobody wants to do that, I don't think. Unless like you are, again, extremely paranoid. Yeah. In terms of security, now here's that privacy versus security argument. In terms of security, it depends. That's the bad answer. I think by default, iPhones are slightly more secure just because of like the stronger encryption security that Apple enforces by default. Android, remember, is multiple companies. iPhones are built by one company. So it's much easier for Apple, the company, to control the software and the hardware that's being run on every single device compared to like Google, Huawei, LG, all the companies that make Android phones. They can each be running slightly different configurations of the same operating system. So in that sense, they're slightly less secure. In terms of privacy, both Google and Apple collect your data. To what extent isn't exactly known. And like again, my personal recommendation is that Android is slightly more customizable and you can tailor it a bit more towards your needs. Whereas with iPhone, it's a bit more closed in terms of the settings that you can change as a user without having to like jailbreak your phone. Any other questions before we move on? Great. I will try to speed up because I do want to get to the demos because those are the exciting part. For texting and messaging, a lot of services like Facebook Messenger, WhatsApp, which is run by Facebook, and Snapchat. I don't think Snapchat's run by Facebook. No, okay. But Facebook Messenger, WhatsApp, Snapchat, all these texting services, still any social media, direct messages, they all collect and use your texting data as part of that digital profile. My personal recommendation is Signal. Signal, I think I would argue, is the gold standard in terms of messaging protocols that incorporates end-to-end encryption. End-to-end encryption meaning from the moment it leaves your device or leaves that application to the time it arrives at the application on the other user's device, it is fully encrypted, and only the two parties involved can decrypt that message so that there's no possibility of eavesdropping in the middle. There are other secure texting services. The problem is for them to communicate, you have to both be using the same application. And if like the person you're texting with doesn't use that same application, then you can't communicate. And Signal is a very popular one as well. So that makes it easy to adopt. That's why I recommend that. Social media, another gold mine of data. We share everything on on social media. What I recommend personally is to opt out of the personalization settings within the social media app. for any ads, search history, or anything else that could be collecting your data. And if you're really paranoid, just delete social media. So like that, like there's no real way to make a social media app private. That's kind of the antithesis of social media. So if you're extremely paranoid about this stuff, I would recommend not using social media. No smart home IoT devices. There's no way to make those private. My favorite thing is like when people have like recorded videos of them turning off like the microphone or like an Amazon Alexa, and then like they'll say something, and then Alexa will respond like, "Sorry, my microphone is off." It's like, how is the microphone off if you just heard me communicate? Aside from the host of security vulnerabilities, which we will get into in a future workshop with IoT devices, these kinds of devices are very, very difficult to make private, if at all.
My favorite example is the big Target hack that happened a couple years back, was because of a smart thermometer in an aquarium. I don't know why an aquarium needs a smart thermometer.
Yeah. A lot of stuff of like I guess it's still a trend. A lot of stuff has been being made smart toasters, smart refrigerators, or whatever. The problem with that is it introduces a node on your network that chances are, because of the reduced processing power, it has less security protocols and like standards built into that by default than something like your laptop, your desktop, your phone. So in that sense, they're not secure. From a privacy standpoint, the people that like create these smart home devices, Amazon, Google, I guess Apple has smart home. Yeah, they have smart stuff too. They're still interested in collecting your data, so we don't want to introduce those, especially into your home. Yeah, so no. Demos, great. So here, I think, what was the one demo we wanted to do before, like doing like I said, like we could do like a mini demo. Not Tails. There was like yeah. Oh yeah, the like Google account, checking all the data that they collect on you. So everybody, as a fun exercise, can go to your Google account. You could do it with your school account too. Although I don't know how much data the school account collects on you. Okay, well here, this is my school account. And you can just, I think, go to your personal info. There should be something to download your data. And you would be surprised at how much they actually know about you. For your school account, not so much because it's your school account, but here, let's see. Yeah, I would also recommend going in here and actually changing a lot of these settings. Pause web activity, pause YouTube history. Don't let them use personalized ads. I'm going to turn that off right now. Because again, this personalization, the way they personalize things is by collecting your data in order to personalize it to you. So we don't want that to happen. They used to have a thing here where you could just, yeah. I think that, yep, here we go. So you can download all of the data that Google has collected on you over the years. If this is done on like your main account, for example, I think you will be shocked at how much data Google actually has on you. Like I'm talking like hundreds of gigabytes of data probably is present for you. You can go through all of the different services that Google has.
It's also the same with a lot of social medias, like Instagram. You can download your data and you'd be like surprised with stuff that's kept there.
Yeah. Especially if you haven't made any changes to the settings or configuration. Because by default, these apps are designed to personalize and collect data on you. Yeah.
Oh, I realized that downloading your data, my old high school, they admin blocked it on their account. They couldn't do it. So when you're interested.
Yeah. Wow. Yep.
I guess you can also collect data and use it as well.
Yeah. What incognito does primarily is it stops the data being stored on your local device. So like it won't log your web history. Incognito might prevent your history from being, sent out to Google. They can still collect everything else. They can see what you're searching for. They can see what websites you visit. If you interact with any Google services in incognito mode, those Google services can still collect data on you, even though you are in incognito mode.
There have been big scandals about that.
Yeah. Yeah, incognito mode. I should have put that as like my disclaimer after the legal disclaimer is
Yeah.
like incognito mode doesn't work. But. Okay, cool. So that was a nice mini demo. I encourage you to actually go and do that. Like it is, I did it. I should probably do it again. It is, yeah, it's a lot. So now we'll set up the Tor browser. I actually have Tor browser installed on my device. It's as simple as going to this download link. So I would encourage you to follow along. This can be a follow along activity. If you go to this link, you can download it for your operating system. They do have it for Android. That's the Orbot application I was talking about earlier. Oh, no, they also they do have the Tor browser as well for Android. So if you wanted to use the Tor browser on Android, not just Orbot, which encrypts all of your data with the Tor network, you can do it for that. One thing too, also, this is a good practice to do. I don't do it, but I should. Most of these kinds of applications will include signatures with their stuff. So you can download a, what is this? RXZ. Okay, so that is, I think, is that the signature here? Signature. Yeah. This is a way that you can actually verify a signature. This is done through a cryptographic hashing process, where they will create a cryptographic hash of the application. And then on your end, you can go and verify that that hash makes sense with the application that you download. I'm not going to do that today just for the sake of time, but you can download the application. I'm on Windows right now, so I'll just download that. It's an exe file. You can run it. Linux. It should be like a Debian package or a script that you can run. Mac, I guess it would be a DMG file. I don't know what Macs use. Anyway, so I already have the Tor browser installed, so I'm going to move that over to here. You'll notice it looks awfully familiar, almost like it's built on top of Firefox. Because it is. It's a modified version of Firefox that they've used, and they've put the Tor protocol in it. I'm going to walk you through a bit about it. So over here, we're connected to Tor. There should be, here, is it over here? And then in here, I wonder if I go to, let's see, let's go to like DEF CON. Now notice how slow that was. I clicked DEF CON and it took like, I think a good couple seconds just to load the website. Here, you can actually see that your Tor circuit. So here we got Germany again, Chechnya, and then back to the Onion site. And that is our Tor circuit. It's 3 nodes. The entry node is sometimes called the guard node because that's kind of your entrance to the Tor network. And it's routing it between all those different devices, which is probably why it took a while for us to get there. Here. So let's just here. I can talk a bit about, so you'll notice it's essentially a modified version of Firefox. We can get into some of the details about it. Here is how Tor actually connects. You can use a Tor bridge, which is, they're essentially a way where you can mask that the fact that you're even accessing Tor. This would be in a place where stuff like Tor is censored. You can connect to a device that's a bridge node. That bridge node can then route your traffic to the Tor network separately. You can add in bridges. It kind of acts like a proxy to the Tor network. You can do some more advanced configuration down here. One thing they recommend for Tor is change it to safest. In this case, JavaScript is disabled by default, and basically everything is off in terms of that. So that essentially acts as like we talked about no script. That's an example of it being used. One thing I would recommend is not changing, I'll get to questions in 1 second. One thing I would recommend is not changing too much about your configuration for Tor. Like for example, I don't have uBlock Origin installed because if you change your configuration on Tor, what does that make easier? Figure out who you are? Is that what you
Figure out that somebody is on the network.
figure out that somebody's on the network?
switch up that quickly.
Yes. Yeah. Exactly. Yeah, it would make fingerprinting easier. The reason being is that by default, if you're on the Tor network, you want to try and blend in, not be the needle in the haystack. So in that case, you don't want to change your configuration because then you will blend in, from a fingerprinting perspective with all of the other people on the Tor network. If you make a lot of configuration changes, then it'll actually be much easier to profile you. All right, people had a couple questions.
Can you go back to the list of the entry nodes?
Yeah.
So those are people, or I'm
Oh, wait,
assuming that they use we're using other people's Tor like nodes to access Tor itself. I was a little confused about that, I just want to make sure.
Yeah, so in this case, what you do is there's a separate, if you go to the Tor project webpage, I can actually add this to the end of the, to the resources at the end of the presentation if you want to. There is a way, on devices, you can opt to be a Tor node. It's not done by default. So you essentially act as a server running the software that allows Tor to perform its onion routing and link negotiation. But that is done voluntarily. Like it's not like I2P where every node on the network is running the same software and doing a peer-to-peer interaction. Certain nodes are designated Tor nodes, and then you are just a client that is being bounced between those nodes. So these are individual servers located in these different areas that are running Tor node software.
Is it safe to on the hidden wiki?
Is it safe to go on the hidden wiki?
I'm like the directory for this whole browser.
Yeah, the hidden wiki is a popular wiki. I'm not going to be taking you there because I think there is some less than savory stuff on there. Generally, it's safe though. Like I wouldn't be worried about going to the hidden wiki. For people who have heard about it, this is also how you access the dark web. I'm not taking you to the dark web today because that's a whole other separate discussion. I'm just showing you how Tor can anonymize your traffic. In fact, if I do a DuckDuckGo search for Wikipedia, it's still DuckDuckGo. It's still just the internet with JavaScript disabled. But I can still browse, I can still do everything I want to. I also can access .onion websites, which are considered part of the dark web. I'm not going to be doing that today because, again, out of the scope of this workshop. But my network traffic is fully anonymized through this. We saw the 3 hops that we made within that Tor circuit. Yeah.
Use the border that it puts around the webpage.
Reduce the border that it puts around the web page.
Yeah, it just puts a colored border for reasons.
I don't actually know, though I bet if we Google or oh yeah, that's the other thing. Everything with Tor is purple for some reason. I can't see what I'm typing. No.
Okay, apparently it does it to making it harder to single out users on the basis of their window or screen size. So they just have one size that they just always use.
That makes sense. Fingerprinting can also be done with your canvas size, which is the size of your display. So if all the Tor users have the same display size, then it's going to be very hard to distinguish one Tor user from another. So that actually makes sense from a not anonymity perspective. There was a hand or a question. Yeah.
So is there a differentiation between which nodes are entry nodes, middle nodes, and exit nodes, or does it just kind of randomize them?
I think it's pretty random. When you're configuring a Tor node, I think the only difference between nodes is whether you're just a normal node or an exit node. Exit nodes are the only ones that I think you have to opt into as a Tor node.
Right.
Because at that point, you're actually you are handling the ClearNet traffic and communicating with any website that the Tor user is trying to go to.
Mhm.
So you might not want to do that on for example, a school network.
Gotcha.
I mean, I wouldn't recommend running a Tor node on a school network anyway, but there are for example, there are extra liability risks for running an exit node. Just because you are that device communicating with the servers. Yeah.
Yeah, that server for the links is only accessible via.
The DNS server,
I think so. You
I,
can't get them on a different,
you can't do it on the ClearNet, you're right. Tor doesn't actually, I think, have a DNS server. Like, I don't think
there's a
DNS,
CLV one because it's on.
well, I think that's just how Tor understands it, because the way the hidden services actually work is, I think the Tor client, like when you create the node, it performs a hash of some sort of your Tor node configuration, including like your IP address, and it uses that hash to then, that is your .onion link. Like that, the hash it creates as the .onion. The only way to find that is word of mouth. There isn't like, I can't Google, like I can't like just look up plain text .onion sites. Like, because if I do this, like I'm Googling like normal sites. Like I can't, like I'm not going to be able to find .onion websites. To .onion websites, it's a unique link that you have to pass essentially by word of mouth. Yeah, that's why they're hidden. Yeah.
I think that's a hash of the original like building, like original the format of the original.
Yes, you're spot on with that. That's why the nodes, like I think if I go to DEF CON here over here, it's just a mess. Like I don't even know what that is. The format of the original. I'm not exactly sure. I think in the Tor node documentation, like when you're creating the server, it might explain that a bit. I'm not exactly sure how the process works. That's a good question. Yeah, I don't know. I just know that like it takes the hash of your configuration and that's what presents as your node. Also, there are some nodes, like certain hidden services that you can like kind of get some customization over what is presented. Like I think Facebook, ironically, has a .onion website.
Most, like New York Times does too.
Yeah. And they like I think in those they have like a little thing with like Facebook or NYT and then the hash. I don't know. I think that's like an agreement between them and like the Tor project where they're able to get like that permanent kind of hash for their .onion domain. Yeah.
One good, really good use of that is it seems like strange, but if you're in a country with like an oppressive regime that censors your media, then like that's a really good way to like get access to like something like Facebook or you know news publications that like have outside access and then not get arrested or killed for it.
Absolutely. Yeah. And again, yeah, there's that kind of hidden element of, if it's just a bunch of string of random letters and numbers, it's very hard to identify what that thing actually is. There are ways to identify, but from a quick glance, it's very hard to identify. Yeah.
How do countries and specific companies block for that?
Well, when you're communicating, I mean, if you're communicating over, like over the ClearNet with, but you're using the Tor the Tor browser. Well, one, they can fingerprint your Tor browser because it is a distinguishable fingerprint from other browsers. It can also be the nodes that you're communicating with, because remember, the nodes that are communicating with those servers aren't your device, it's the exit nodes. And those exit nodes are public. The Tor nodes there's a public list of them. So companies can just blacklist those nodes from they're accessing their site.
And then could you use a VPN to do it? Or I was trying to read this at my job and they said like you could use technically Tor bridges to use Tor, but I didn't know what a bridge is.
Yeah, I think we briefly talked about it, but a bridge is essentially, it's a proxy where you're able to communicate with a normal looking server over a port that's not associated with Tor. You can communicate with that server. Granted, you have to trust that server. If the bridge is, malicious, then that's a whole other set of problems. But if you communicate with the bridge is essentially like, it's kind of like a VPN almost. It's just an extra hop before you get onto the Tor network.
That's what I figured. So
Yeah.
you could use a VPN at like or work site that's blocking Tor.
A VPN at a work site. Well, the problem is the VPN is on, if we like drew out the diagram, the VPN is like the 0th hop. It's you, the VPN, then the 3 nodes on Tor. The problem isn't there. Unless, well, it depends on how the worksite is blocking it. The worksite is blocking it based off of like the port or the entry server you're communicating with, then that would be a way to mitigate that. Although I would just recommend using a Tor bridge. If it's on the other end where like a website is blocking Tor, by checking the exit node or checking what, what your user agent looks like, then a VPN might not be very beneficial for that because there's no real way to route it after. Well, I say that there is a application on Kali Linux called Proxy Chains where you can chain multiple things together and get really creative with it. I don't recommend it because that will take your like latency and network speed from slow to abysmal. Like good luck loading Gmail. But you can, if that is a scenario that you're concerned about, there are ways to mitigate that through Tor bridges and through VPNs. The thing is, from a privacy standpoint, I don't recommend using VPNs because VPNs are, instead of a decentralized network of devices that are handling your communication, it's one company, one central entity that's handling that. And I think by law, and like if it's a US VPN, I think by law, they are required to keep logs of their user data. So if you're concerned about anonymity and privacy, Tor would be a better alternative to that. So I typically don't recommend running a VPN with Tor unless there are specific scenarios where it would be beneficial.
I think it's counterintuitive, but the exact technical reason for why, I don't know.
Yeah.
To do that, like it does the opposite effect.
There are varying that it's like Vim versus Emacs. Like it's like there's a bunch of different see there's back and forth on whether or not you should or shouldn't use a VPN with Tor. I will say no and leave that for you to decide. And sorry, I didn't hear the last part. Torrents over Tor. Yes, in fact, it's I think it's very common because like Tor, it uses a SOX proxy. So as long as your torrenting service or your any peer-to-peer service has an option to use a proxy, like a SOX proxy, you can run a Tor service on your device and then route that through that proxy to the Tor network. Yeah.
Like you said before, at Google, you sign in, they track all your data, right?
Mhm.
If you were on Tor and signed into Google, they still track your information and stuff.
Yes, very good question. So that's kind of gets into that OPSEC part that I mentioned, that operational security. You can use Tor and be very private. The second you sign into your Google account, you're not private anymore. They know who you are. That goes for a lot of websites that require accounts to sign in. So again, that comes down to a discipline and an OPSEC perspective where you have to be conscious of what you're doing on the Tor network, even though your initial browsing might still be private. Does that answer your question?
Right.
Yeah, good. Yeah, so every 10 minutes, I think or maybe every certain number of connections, it'll refresh your identity. Like here, if I refresh this, maybe it might give me a different. Okay, it's taken a while. Yeah, see, there we go. Cool. So it just changed. See? So Germany, Finland, and then Italy. Cool. And you can see it took a while because it had to recreate that circuit, perform the negotiation with those devices, and then route my traffic through. That took like a good 5 seconds, 10 seconds just to complete that operation. Yes, so if you refreshed your identity, like for example, here now I'm in Italy. Previously I was in Czechia. Yeah. The website would see Czechia and then Italy, and they wouldn't be able to correlate those two. The only thing they would know would be, yeah, somebody from Tor accessed us within 10 to 20 minutes, but from two different Tor exit units. So your session would be different. And you can also, even if you want to if you want to be like really paranoid, you can clean your identity right here, and that just completely tosses everything and just redoes it. So probably another network, right? Like if I go to DEF CON again,
So. Are those your saved bookmarks?
yeah, so
Okay.
one way, because like I mentioned, Tor doesn't have a DNS service, like you can't just search for stuff. Bookmarks are how I keep track of like sites that I'd like to visit. Here, and I bet this is gonna be another Tor, yep. They love Germany for some, Germany, Switzerland, Germany, okay,
Always the European countries,
yeah.
or like Turkey.
I apologize, I think we are a bit over time. I don't think I'm gonna be able to do the full Tails demo. As a makeup for that, in the end of the references, I will include a video on like configuring and using Tails. Tails, here, let me see if I can pull up the so here, so Tails, we go to Tails OS. The idea behind Tails is it's the amnesic incognito live system. The idea with this is instead of running the operating system on your device, like Windows, Mac OS, Linux, this can run inside of a live operating system, which runs on a USB. In fact, I think one of my USBs has Tails on it, though I'm not exactly sure. The point of that being, that operating system is only present as long as your USB is plugged into your computer. So it's amnesic in that it's living entirely in your system memory. Nothing ever goes to disk. The other thing that's good too about this is, like I said, it routes all your traffic through Tor. It has encrypted storage on the USB, so if you want to save configurations, it can do that. It can create encrypted vaults. And it's overall just a very secure and private operating system if you're very concerned about your privacy and security. And it has Tor browser on it. It has Firefox ESR extended security release or whatever, or extended support release. Yeah, I don't think I'll be able to do the full one because we are a bit over time, but I will include a video at the end that will show you how to set it up and use it. Yeah. Okay, so I think that about ends it. Here, let me see if okay. This runs through some of the steps. I will include here a video or two on how to do that. Cool. And then here are a lot of the resources. I just want to briefly talk about the resources. These are two good videos from Computer File on how Tor works, and they go a bit more into depth on the Tor hidden services. This is a video on securing and anonymizing your online activity. That touches on some of the stuff we talked about in the second segment of this presentation. I also include two books, which I use as my primary references for this. The Art of Invisibility by Kevin Mitnick and Extreme Privacy, What It Takes to Disappear by Michael Bazell. The Art of Invisibility was a very interesting read, partially because of the author's background. For those who don't know, Kevin Mitnick was a very famous computer hacker in the early to late 90s. And there are plenty of stories of him online just talking about how he was constantly outrunning the FBI. Granted, this book will not teach you how to outrun the FBI. Please do not try to outrun the FBI. But it goes much more in depth about stuff that I talked about in this workshop. And if you weren't paranoid before, you will be paranoid after that book. And then Extreme Privacy is much more of like a guide on how to implement privacy practices, privacy best practices for you. Though it does take a very extreme perspective on it, though you don't have to implement everything in that book. I just included because a lot of what I included in here was taken from that. And then these are also some other, this website corresponds to this book, and privacytools.io also has a bunch of guides. So that is it. I hope that you enjoyed the workshop and learned a thing or two. So thank you.
Just a few quick announcements. We have Hivestorm signups on the Discord. We get a unlimited amount of teams, so please do it. It's fun. It's really beginner friendly, and if you don't have a team, we'll pair you with people. And if you are really interested in this stuff, the day before, 2 days before Halloween, we're gonna have a general meeting on like the more spooky stuff of this. So it's gonna be dark web drug markets, the carding markets, and all that kind of cool stuff, and like the human implications of these privacy tools in a like dark web scary jack-o'-lantern type content. You'll see it, it'll be fun.
Yeah.
Okay.
We will not have a workshop on Halloween though.
Yeah, no workshop on Halloween, go trick or treat.
Go trick or treat, yeah. Cool. Thank you guys.